Hello students, today we're going to be looking at right triangle trigonometry. Please make sure you're taking notes as you watch and complete the survey that follows. Now trigonometry might be something new to some of you. Some of you might be familiar with it already depending upon who was your teacher last year. But we typically associate trig with our right triangles. Now we don't always have to do them with right triangles. We can actually do ones with acute and obtuse triangles, and you'll see that with the law of sines and cosines later. But typically we always relate them to a right angle triangle in this class. Now you're going to see more in pre-calculus and calculus with different applications of trig, but for now we're going to be focusing on our right triangles. So trigonometric ratios, since every right triangle has at least the right angle in common. If we were to have another angle in common, the two triangles are similar. So what ends up happening is when we talk about these ratios, they're all going to be the same no matter what, as long as we're talking about two similar right triangles. So similar right triangles have equivalent ratios for their corresponding sides called trigonometric ratios. So the first one we're going to talk about is pronounced as sine. So you see it up here as sine, S-I-N-E. And we're always going to be focusing on a right triangle with an acute angle. And everything that we do, or as we set these up, is going to be based upon this angle A. But both of these, all three of these are going to be can be used for both acute angles that are here. We're not going to be using with the right angle here ever. It'll always be the two acute. So what we have here are two legs. The first leg is the one that is opposite of angle A, and the next one is the one that's adjacent to angle A. The third piece is always the hypotenuse. So for our first ratio, as you see, I'm not going to write the E down here. I'm just going to have sin of A. So this is the sine of angle A. Its relationship, its ratio, would be found by finding the opposite side of to angle A and compare it to the hypotenuse, and that would be its trig ratio. So just to give you an example with this, to find the sine of, say, this angle S here, I'm going to identify those key pieces. Well, the first piece would be opposite, so the value here would be 63 would go on top, and it's over the hypotenuse of that triangle. In this problem here, it's the 65. Similarly, if I did sine of R, well, now it's going to change positions, since now the leg opposite is the 16, so the top value would be 16, but it's over the same hypotenuse as 65. So for sine, you're going to have the same denominator, but the numerator is going to change depending upon which angle we're talking about. The second one here is cosine. So it's sine with a CO in front, again to the same right triangle, all based upon angle A. The different relationship between this would be, instead of doing the leg opposite, we're going to be looking at the leg that's adjacent to that angle here. So it's this piece here, and still comparing it to the hypotenuse. So let's do an example with the cosine. Once again, we only talk about the two acute angles, and I'll show you why. But as you can see, I just want to point out one more time, is the cosine here we abbreviate as COS. And that's why the sine, we only just drop the E, because typically we always use 3 letters for these problems. So in this example here, we're going to look at the cosine of U, and sorry, that should we say cosine of W, not cosine of U. So the first one here is, if we look at U, the adjacent piece is this leg here, 18, but the hypotenuse is 30. Now for W, this reduces. We always want to reduce our ratios if we can. 18 over 30 has the 6 in common, so when we simplify, we get 3 over 5. Now we're going to do the cosine of W. The numerator of this ratio is going to change because we're talking about a different angle, so the top number would be 24, but the hypotenuse is still the same number. And once again, we can reduce this ratio. This reduces to 4 over 5, since again there's a 6 in common. So we have 3/5 and we have ourselves 4/5. The last one we have is called tangent. Once again, we're looking at a right triangle with the two acute angles, and we're basing everything off angle A. So we've compared the leg opposite to the hypotenuse. We've compared the leg adjacent to the hypotenuse. All that's left is to compare the opposite and the adjacent leg, and that's the tangent ratio. It's very important the order that these guys are in. The tangent, abbreviated as TAN, is the side opposite on top over the adjacent side on the bottom. So once again, that is the opposite over adjacent. You need to make sure you remember which order that goes in. So let's go through and do an example with this one. So find the tangent of S. If I locate where S is here, okay, if I want to find the opposite, it would be 63, and the adjacent leg would be the 16. So as you can see in this problem here, I'm not using the hypotenuse at all. So when I do the tangent of R, say the R of angle R is down here. When I do opposite, the 16 is now on top and the 63 is on the bottom. So in cosine and sine, the hypotenuse was always the denominator. However, with tangent, we have ourselves reciprocals. And we're going to use the same numbers, it's just one's going to be on the top depending upon which angles we're talking about. So what I want you to do right now is pause the video and find the sine of the two acute angles. And when you are done, hit play to see the answers. So here are your correct answers for sine of x and y for both of the triangles. Please make sure you are simplifying your ratios. As you see over here, this simplifies to 3/5 and 4/5. If you're not sure where these numbers are coming from, please make sure tomorrow you are asking that in class. Let's do now one with cosine. So please pause the video and try to find the cosine of the two acute angles here. What you need to do first is actually find the hypotenuse in both of these problems, since the cosine is adjacent over hypotenuse. What you find for number 3 is the hypotenuse by Pythagorean theorem is 15, and for number 4 it is 34. So for both cases, the ratios all reduced. Please make sure you check your answers that you have the correct ones there. If you need some more time to look at the answers, please press pause. So we're going to do one more using those same triangles. What I want you to do now is find the tangent of those two angles. Hit pause now and try. So for the tangent of these, you don't necessarily need to find the hypotenuse, since it's opposite leg over the adjacent leg. We don't have to worry about the hypotenuses, but it's good to have sometimes. But for these here, once again, we have reduced ratios and they should be reciprocals of each other. So just check your answers and make sure they're good. One other thing I want to go over before we end this is the angle of depression versus angle of elevation, and actually think about what those words mean in the English language. So what we have here are two angles. We have this angle down here and the angle up here. So this difference is, where are you standing? Are you the person down here, or are you the guy that's up at the top of the mountain there? So, well, I call it a mountain, but it's not necessarily a mountain. It just depends on the problem that you're looking at. So this guy down here, who has identified our infamous little thief, is what he looks like there. He is looking in this upwards direction towards that thief. That would be the angle of elevation. Think of like an elevator typically brings you up to a floor. Yes, I know it goes down as well, but we think of elevation heading upwards. And while this guy is in his happiness because he has stolen whatever he has stolen, is looking down on that man, the word depression kind of implies that downwards movement. So that angle here of his eyesight going downwards is the angle of depression. So what I want to do is actually do a combination and show you how to use the sine, cosine, tangent ratio to solve for sides of triangles, as well as explain the depression and elevation, those two angles there. So what I'm going to give you in this example, so you are skiing on a mountain with an altitude of 1,200 meters. The angle of depression is 21 degrees. About how far do you ski down the mountain? So in this one here, we're talking about depression, so that's the eyesight looking downwards towards the ground, has an angle of 21 degrees. And the altitude of this guy here is 1,200 feet. We don't know what this side of this right triangle is here, so we need to solve for that value. So what we want to analyze here is, what pieces do we have in relation to this angle? Well, we have the opposite and we have the hypotenuse. And going through our sine, cosine, and tangent ratios, the sine one is the one that has opposite over hypotenuse. So we know we're going to set it up using those two pieces there. I'm actually now going to substitute our values in. Now instead of saying angle A like we've been doing, we can actually put an angle in there. In this problem, we have the number 21. What I'm going to do before I actually evaluate sine of 21 is move everything around first and then actually convert. So what I need to do is get x out of the denominator. Since this fraction bar implies I'm dividing by x, to undo that I'm going to multiply both sides by x, which causes these two x's to cancel out. But I need to get x by itself, so I'm then going to divide by 21. Excuse me, sine of 21. That is an entire entity that goes together. Now, if you did not know this, you can actually evaluate this sine of 21. This is not sine times 21. This represents a function. I'm looking for the value of sine at 21, and this one specifically is 0.3584 rounded. So I can divide 1200 by 0.3584. and I get 3,348.21 feet, and that's going to be the length of this hypotenuse here. you're not sure how I got any of these numbers, please make sure you take note to ask me tomorrow in class. What I want you to do now is to change this value to 28 degrees and come up with the answer. I'm going to ask you to put the answer to this in the survey that is following this video. Okay, so what to do now? What I want you to do is actually research and see, is there an easy way to remember the difference between sine, cosine, and tangent? I'm going to ask you tomorrow if you have come up with some fancy way, and just write it down somewhere on your notes. Make sure you do the survey that follows, and if you have any questions, do write them down so you ask them tomorrow in class. I'm going to show you a couple more examples tomorrow how to solve specific problems, but please make sure you are writing down any of the questions that you might have. I'll see you tomorrow.